Hello, and welcome to Creative Approaches to Fire Protection in Historic Buildings. My name is Nate, and I'll be walking you through some techniques and approaches and tools with some examples of how we've approached historic buildings from a fire protection standpoint to achieve a variety of aims. Today, I'll talk about three main areas. The first is a general overview of historic structures fire protection. I'll look at the key challenges and opportunities. We'll look at some of the beneficial qualities of historic buildings, as well as active and passive fire protection and the differences between them. We'll look at fire protection design resources. If you're trying to achieve something without having to blow the budget or give up on a specific design intent, how can you do that using the codes as your basis, looking at the appropriate standards in the National Fire Protection Association or SFPE, looking at performance-based design. And then looking at resilient solutions, what is the notion of this hybrid approach where you're combining a codified approach with an approach to performance-based design? I'll look at a few examples that we've dealt with over the years, including the Tweed Courthouse in New York, the Press Building in Los Angeles, and the AMPAS Museum in Los Angeles. The landscape. Historic structures fire protection is probably one of the more challenging types of fire engineering you can do. For the same reason, it's probably one of the more types of architecture you can find yourself involved with. It's very much about the things that you can't see that define how well or how difficult the process can be. We're looking at here the Macintosh building, which is part of the Glasgow School of Art. And it first caught fire in 2014. And while it was being restored, again, it caught fire and ultimately has been a real loss for the school. But in part, there were questions and remain questions as to what could have been done differently, how they could have approached the building differently. This is the question that we ask every single time that we approach a historic building. On the one hand, the building has been there for many, many, many years. And on the other hand, the building may need some improvements, and especially if you're looking at a change of use, a significant alteration, or extensive repairs. I've heard that fires are rare events, and indeed they are. But if we look at the numbers strictly in the United States, during the time that we will be having this discussion, we'll have approximately one fire in a structure approximately every 64 seconds. And with that, we will have a call for some kind of a fire about twice as much as that. So inherently, the codes mandate some level of protection in nearly all structures, with the assumption that the occupants of that structure will at some point face a fire, even though when you look at the larger statistical picture, it's not necessarily something that you would expect to happen at any given moment. For this first part, I'm going to look at, as I said, the challenges and opportunities posed by historic buildings. Historic buildings used technologies that were appropriate to the time they were built. Some of the historic buildings may have been constructed using codes, some maybe not. And what we very often find is, irrespective of what kind of code the building was constructed to, many, many things have often changed over time in those buildings. What we do find is that the ones that we're typically working on, they very often have some inherent beneficial qualities. It may be that they're a small size, which actually poses less of a threat to life safety. It may be the materials of construction. Maybe they have large volumes that are capable absorbing a great deal of heat. Either way, historic structures were built according to the state of the art at the time and are generally deemed safe and viewed as safe. It's when we start to make alterations to them or a change in occupancy that we really have to think about what can we do differently, and we have to navigate the complex network of codes that guide us. As far as active fire protection systems, these pose special challenges for existing and historic structures. One of the main reasons why these pose challenges is because these types of systems were often never contemplated at the time that the historic structure was built. Because of this, we find ourselves in a place where trying to find space or trying to provide an adequate area to actually place the fire protection sprinklers becomes a huge challenge for the designers. Passive fire protection systems, on the other hand, were part and parcel of how many of these structures were constructed and designed in the first place. Whereas we had very few options for active systems, passive systems really took the place of the active systems in many of the historic buildings that we deal with. I'm going to talk about something that we've all encountered, and that's the notion that the structural systems in historic buildings are sometimes vulnerable. Now, on the one hand, you may have a structure that's all concrete or blockwork, stone, or similar, and it's inherently has fire-resistant properties. On the other hand, you may have structural systems that use something like cast iron, and cast iron we know has inherent challenges, especially when it comes to fire. In this diagram, you can see an example of some of the challenges that we face. Now, while cast iron may be a very strong material, it sometimes can be brittle. Now, that brittle behavior can come about as a result of a number of things, and it can be expressed, for example, when you have freezing conditions where water gets inside and it actually causes the column to expand and crack. Or you could express that brittle behavior through the fire. And if you have intense heating and then sudden cooling, as you might expect in some fires, that can actually cause a brittle failure. And those brittle failures can lead to catastrophic collapses or failures of the actual structural members themselves. Concealed combustible spaces. By modern standards, we often are dealing with some level of combustibility in what we would otherwise think of as non-combustible buildings when we're dealing with a historic structure. Now, very often you'll see a building like Notre Dame that is primarily non-combustible, but it contains in its hidden spaces lots and lots of timber. This isn't just Notre Dame, this is actually many older structures throughout all of our cities. And in some cases, the structures are, of course, entirely made out of wood. So what we've learned is even when there's nothing in the space, these types of spaces where you have combustible construction can become a huge challenge. One thing that we can do is that we can also look towards modern research, however. So modern research shows us that wood, especially if it's dimensionally appropriate, can actually resist the effects of fire. So this is why, for example, we've changed recent codes in the recent years to include type 4 construction, and we're now actually building wood skyscrapers. So if we can build a wood skyscraper, why is it that we can't actually make the wood in our existing historic structures work well, especially when those structures are constructed using members that are often much larger than what we would use in conventional heavy timber construction? Here we're looking at a few pictures of the Notre Dame Cathedral. I bring this up because it's timely. and it relates to some of the very topics that I'll be going through today. We have the cathedral in its original condition. Then in the middle, we show a model scan of the cathedral where the roof construction and the spire, which was made out of wood, are highlighted. Next to that, the actual plans for that. Now below this is where we see what it actually looked like, both before the fire, during the fire, and after the fire. The issue being when you get to a certain point, even heavy timber construction can fail to serve you. But perhaps we can do things to address that inherently with wood construction. Let's take a look at a video where we're going to learn about some of the fire tests that have recently been performed to validate the very presence of wood in modern construction. This is instructional as to how we can address some of the same problems that we might deal with in historic building construction.
We designed a series of 5 tests to investigate the fire performance of CLT.
To make the test as realistic as possible, we built a 2-story, full-scale structure at the Bureau of Alcohol, Tobacco, and Firearms Fire Research Laboratory.
The floor plan was a typical 1-bedroom apartment that we jam-packed with furniture to fuel the fire. Tests 1 through 3 were conducted without the use of a sprinkler system. Test 2 included 30% exposed CLT ceiling in the living room and bedroom, while the other CLT surfaces were covered with gypsum board. To begin the test, the fire was ignited in a lower kitchen cabinet. As the fire grew, a layer of hot gas began to form on the ceiling. The hot gas continued to expand until flashover occurred at about 12 minutes into the test, igniting everything in the kitchen and living room at once. From here, the layer of hot gas spread into the bedroom, and the process was repeated. The gas layer expanded until flashover was reached, and the entire room was engulfed in flames. Flashover in the bedroom occurred roughly 6 minutes after flashover in the kitchen and living room. Around 25 minutes into the test, the fire began to decay. After the fire started to die down, the apartment door failed at 30 minutes. However, the fire did not spread into the hallway, maintaining a safe environment for firefighters and people leaving the building. As the contents of the apartment burned out, the fire self-extinguished.
For the 4th and 5th tests, we explored the effect of an automatic fire sprinkler system on the fire performance. The CLT was left completely exposed for the 5th test, and we delayed the activation of the sprinkler system for 20 minutes. Temperatures soared to around 700 degrees Celsius. But once the sprinklers were activated, cooled to approximately 50 degrees Celsius in a matter of minutes. The sprinklers effectively suppressed the fully engulfed apartment.
These tests demonstrated that it is possible to build a cross-laminated timber building that's fire-resistant, even with exposed CLT. Researchers now have a better understanding of the performance of timber buildings under fire conditions. The data collected will help inform building codes, address the safety of occupants, and lead to safer firefighting in CLT buildings, allowing designers to bring wood buildings to new heights.
While a lot of this is, applicable to, for example, CLT, a great part of the research was focused in on the inherent fire resistance of heavy timber, and especially the charring characteristics. This is true for both heavy timber structures that are provided with sprinkler protection and heavy timber structures that are not provided with sprinkler protection. The beauty, of course, of heavy timber is that it is a passive fire protection system in of itself. It is when you are trying to achieve specific ratings that you may have to complement existing heavy timber with certain types of non-combustible coverings. And in the case of the testing that led to the changes in the International Building Code, for example, the material that was used to achieve those higher ratings was gypsum. Now, in these cases, I wanted you to note that part of the test regime that was run included non-sprinklered cases. This is important because many of the historic structures that we deal with are not sprinklered. And as we all know, sometimes this can be a major challenge to introduce sprinklers. But perhaps by treating some of the exposed wood in concealed areas we can actually achieve some of the aims that we're trying to achieve with sprinklers. And I think that's one of the key lessons to take with you, is that sprinklers are one way to achieve the intended aims of a fire life safety design, but they're certainly not the only way to do it. In many of the historic buildings that we deal with, we're also lucky enough to deal with very robust materials. Here, for example, you can see board-formed concrete columns and beams. These are part of an existing historic structure that was being renovated. And while you have to clean up some of the spalling and areas where the structure may have come apart over the years, that is quite doable, and you actually are left with a very robust structure at the end of the day. This is true of many, many historic buildings that we wish to save, and in some cases will result in a life safety system that will exceed what we would even anticipate using the current codes. When I speak of active fire protection systems, of course, I'm referring primarily to fire sprinkler systems. Active fire protection systems are those systems that involve initiating elements that trigger complex responses by one or more building systems comprised of multiple elements that act together to limit the effect of smoke and fire. This sounds complicated in part because it is a bit more complicated. Active systems require that we rely on lots of pieces working together. Common examples of these types of systems, of course, are fire sprinklers, smoke control or venting systems, automatic closing fire shutters, which may be part of a passive system, and emergency communications alarms that are typically used in many of our modern buildings. Here you can see where with sprinklers and with fire alarm systems, you can significantly decrease the death rate. This happens to be for home structures, but it's equally applicable, if not more pronounced, in other types of structures and occupancies. Passive systems, on the other hand, are really the oldest form of fire protection. They're those systems that do not require a sequenced response to aid in the control of smoke or fire spread. They're always in place and are constantly working to reduce fire spread before a fire event starts and to assist in the safe occupant evacuation during a fire event. So passive systems are quite interesting because sometimes a passive system will contain an active element. For example, if you have a door that's an automatic closing door, you might say that's part of an active system, but this is where the line blurs a little bit. The point is that it will fail-safe close typically, and then it will allow the barrier systems in the building to control and contain the effects of fire. Containing the effects of fire serves a couple of purposes. First, it prevents the fire from spreading to many areas of the building simultaneously. And second, it allows for time for occupants to move away from the hazard, out of the building into a point of safety, and time for firefighters to reach the building and control the fire through manual suppression efforts. Active and passive systems work together, of course. That's the reality. And what we find in historic buildings is that the trade-offs between active and passive systems are essential. You have to have the ability to trade one type of system for another if you're intending to preserve something that was not designed originally according to a specific code. So you may have sprinklers that may be used to substitute for a lack of passive barriers. Or alternatively, if you can't provide sprinklers, you could use passive barrier systems to achieve a similar level of safety. We are definitely biased towards providing sprinklers in these types of structures, but sprinklers are not the only solution, as I mentioned. Again, it's about containing fires and buying time for both occupants of the building and the firefighters there to respond to building fires. Part 2, let's look at the rules of the road. Historic buildings, fire protection, design resources. In the background here, you can see the Stockholm School of Architecture. And I am a fire protection engineer, so I unfortunately have lots of pictures of buildings that are on fire. Now, how can you use design tools to come up with smart solutions? Well, in the United States, we follow prescriptive codes largely. But even in our prescriptive codes, there are performance-based aspects of those codes. These prescriptive codes have served us well, and they have served us well for well over 100 years for more than 99% of the buildings out there. There are, however, some projects for which the sole use of prescriptive approaches may not yield a result that is either cost-effective, sensitive to your particular aesthetic or the historic features of a building, or responsive to other unique characteristics of the structure. So it is when we use the codes and standards together with performance-based design that we can achieve better results for the remaining 1% of those buildings. So first, I'm going to walk you through the basics. The International Existing Building Code is one of the codes that many jurisdictions across the country adopt. It's designed to encourage the use and reuse of existing buildings. The whole purpose, in other words, is to allow us to make effective and safe restorations to allow for the continued use of buildings. And within this subset is a subset of historic buildings. Some states, like California, have their own state historical building code, and it works in concert with the existing building code. 2, standards such as NFPA 909 or 914, the Code for Protection of Cultural Resource Properties, museums, libraries, and places of worship, or the Code for the Protection of Historic Structures, are both examples of standards that are sometimes applied very much like a code, or they're applied in the context of the code process. Finally, we have the guide. The guide is produced by the Society of Fire Protection Engineers. The guide was developed to work in concert with the standards and the codes to allow for performance-based design. I'll touch on this in just a moment. In the International Existing Building Code, there are key areas of concern, of course, which is to establish what the minimum requirements for safety are. One of the principles in fire and life safety is that if you're going to touch a building, if you're going to work on it, you should at least meet basic standards for fire protection and life safety. And so this code has been set up to address those. It provides these through a compliance framework, which lays out prescriptive compliance methods, what's called the work area compliance method, and the performance compliance method. The performance compliance method is there to help us address 3 main categories: fire safety, means of egress, and general safety. It's here that we're able to look at the specifics of a historic structure and to evaluate them on a comparative or relative basis. And this helps us understand if what we're doing is making the structure safer, ultimately, or potentially less safe through unintentional modifications. We've all heard of cases where structures have been unintentionally made less safe. One that immediately comes to mind, of course, is the Grenfell fire. In the Grenfell fire, they had a building where they added a combustible facade system, and that combustible facade system ultimately made the building less safe, even though it was designed and intended to improve the quality of life for the people in the building and actually provide better conditions overall for the energy and aesthetics of the building. NFPA 909 contains many resources. These two, 909 and 914, are probably the most referenced when it comes to historic buildings. So even though 909 is addressed to the protection of cultural resource properties, museums, libraries, and places of worship, many of the principles in NFPA 909 are often applied to other historic buildings. The idea is, again, to be able to understand what the improvements are or are not doing, whether they are affecting the life safety in the building, and how you can quantify that in a way that everyone can understand what's happening and if they're comfortable with that. NFPA 914, of course, prescribes the minimum requirements for the protection and recovery of historic structures from vulnerabilities while preserving the elements, spaces, and features that make them historically or architecturally significant. So this is a recognition that there are features in these buildings that may not comply with the current codes, but which are extremely important in terms of the overall purpose and history of the building and its continued use. The SFPE performance-based process, of course, is used in conjunction with both of these standards and with the international existing building code. This process was developed by the Society of Fire Protection Engineers specifically to address complex challenges for fire protection. And these challenges don't always have the same solution. The codes tell you to provide sprinklers, or they tell you to provide a fire alarm system or smoke detection. This approach only asks you, what are your goals? What are your objectives? And what are the criteria that we must meet to be considered as successful? By establishing those for any given problem, it doesn't have to be for an entire building, but it could be, or for a specific problem that you're trying to address in an existing historic structure, you can solve that problem. And so this is effectively a communications tool and a methodology for analyzing hazards. The method comes with more than the flowchart, of course. You have guidelines for both the practitioners, guidelines for the authorities having jurisdiction. You have compendiums of resources for fire protection calculations, smoke control, and numerous tools. In performance-based design for historic structures, we start with the design fire, which is what we see here in the middle at the bottom. That design fire is what we use to evaluate the safety for different scenarios in the building. In any given building, you may have multiple scenarios and multiple design fires. But once we know what we're facing, we can address that through a thoughtful analysis with thoughtful solutions that fit with either what's there with minor modifications and sometimes with substantial modifications. Other times we can have an entirely different approach or multiple approaches that yield the same result. And this is the beauty of the performance-based method. And this is why, in part, it works so well with historic structures. So in this last part, I'll walk you through achieving resilient solutions. I'll walk you through some examples of projects with which I have personally participated or my colleagues have participated over the years. Buildings, when they're maintained as they were intended to be, with minimal disruptions, absolutely serve our society. They do hold a special place for all of us in preserving tradition. And it's one of the reasons why we have to take special care to actually preserve these buildings. Resiliency is a term that's often used to describe how a building responds to threats of any kind. For example, the USGBC defines resilience as the ability to prepare and plan for, absorb, recover from, and more successfully adapt to adverse events. Sometimes resilience is just about outlasting the other guy. So in the case of a historic building, we can already say that these buildings have shown us remarkable resilience over time. Sometimes they fall out of use, and the very interventions that architects and engineers do to work on these buildings can make a huge difference and continue and allow these buildings to continue showing their resilience over time. What happens and what we have to watch out for is when we perform specific alterations or changes to these structures. That's when we may get into trouble, but it's also an opportunity to truly preserve for a much longer time and for more people what was there and allow us to get that continued use from these beautiful structures. So I'm going to touch upon this notion of the hybrid approach, which I referenced at the beginning of this presentation first. The real world is not purely code, and the real world is not purely performance-based, at least not in most of the buildings that we work on in the United States. Alternatively, many of the projects that we work on involve elements of performance and elements of prescriptive. It's not practical to look at the entire building using performance-based design at this time, but it's also not necessarily practical to rely upon prescriptive requirements. Prescriptive requirements were developed with the notion that they would work for most of the buildings most of the time, and they've done remarkably well at that. So I'll briefly walk you through some examples of how some of the approaches we use have helped us address complex challenges, sometimes with and sometimes without fire protection sprinkler systems. And we'll walk through some of these changes together. We'll look at the Tweed Courthouse, the Orange County Press Building, which served the Los Angeles Times, and then the Academy of Motion Pictures and Sciences. This structure is a fusion of new and old. Before I go there, I'll talk about what's on everyone's mind, which is, of course, how do we deal with the constant challenge of when we're asked to provide fire protection or sprinkler systems in these beautiful old structures? And very often, you'd be surprised, but it can be done in many cases. And there are reasons why it has become much more the norm over the past few years. For example, in the structure that you're seeing right now, this is one that I'd worked on for several years. This structure has some sprinklers in some areas, but in other areas that were sensitive because of aesthetic or other reasons, we did not have sprinklers, or we had modifications to what would have otherwise been required by NFPA 13, which is the standard for installation of sprinkler systems. The bigger issue, of course, for many owners is cost. You have to sometimes look to more creative approaches to understand how we can achieve the level of protection that we desire without actually destroying the budget and having budget left to do many of the other things that we wish to achieve in these historic structures. The general approach is that we first start by identifying the historic building code requirements. These are through the use of the codes that I described earlier. Then we focus. We focus on the most important challenges. What are the issues that we know are of the greatest concern to the authorities having jurisdiction, i.e. the fire marshal or the building official? Next, we set up a way to work together. We work together not as just the design team, but as the design team with the authorities having jurisdiction. In my experience, the AHJ, or the authority having jurisdiction, is one of the most critical members of this team, because the AHJ lives with this building in terms of their response to it and their responsibility for being able to protect it down the road. And once we understand what the stakeholders want and what the building needs and what the baseline requirements are, that's when we can start to consider the holistic approach. This is an approach that may start with a prescriptive basis, but identify a key challenge. Some may call it a deficiency. Others may call it an alternate means and methods. But it is this approach that lets us often arrive at solutions that can meet our needs, whatever those needs may be. As I alluded to, engagement is the key. The way that we tackle performance-based design with prescriptive design makes all the difference. The approach should, of course, adhere to our basic codes, the standards, the SFP guidelines when we're dealing with performance-based design. We should look at our analysis methods, tie them together with peer review references. The key is you can't go out there and make up your own methodology necessarily and expect to have it received well. You should be using methodologies that have been peer reviewed or that at least have a basis in literature. Next, we look at what information needs to be presented at the right time. Many of these projects can seem overwhelming to an authority having jurisdiction who's responsible for reviewing them. A key is that you present the right information at the right time. This may mean presenting it in a staged fashion, and it may mean presenting concepts before you present solutions. You need to make sure that all of the stakeholders are engaged. The authority having jurisdiction will be a focal point of making this process happen. We have the technical means to make this happen. The issue is whether we have the capabilities in terms of communications to make these types of solutions happen. And then we set about our analysis. We use our best practices in the analysis. We pull together the right documentation, and we can demonstrate both quantitatively and through experience as a team that the solutions are robust. And very often they tie back to code solutions. The final part is preparing the final documentation. This documentation lives with the buildings. One thing it's important to mention is that in historic buildings, and when you're doing a hybrid approach, where say you're removing sprinklers in lieu of some other type of feature, it's extremely important to list out what those limitations of the structure are. For example, in some structures, we may have a case where we have a fuel-controlled condition. In other words, we don't have sprinklers, but we also know that a particular space is not designed nor has historically ever contained very much in the way of fuel load. These are the types of assumptions that have to be documented, and the limitations have to be explicitly documented so that everyone knows, from the user to the authority having jurisdiction, what the building can and cannot achieve with the proposed design. Creative approaches also includes specialized tools or technologies. So one example is aspirating smoke detection. In aspirating smoke detection, we very often have a tool that allows us to know about a fire long before we would otherwise know about it. Aspirating smoke detectors are much more sensitive, or can be the same sensitivity as a standard detector. But what's really interesting about an aspirating smoke detector is that an aspirating smoke detector is often invisible. You might not realize that there are numerous aspirating smoke detectors in this very image. It is because they're hidden. When you go in theme park rides, you don't want to see smoke detectors, so you use an aspirating technology. The beauty of that technology is not only is it efficient, but it's something that is less obtrusive to many historic structures. And it's for this reason that many heritage sites rely on these types of systems. Everything from the American Museum Planetarium to Hearst Castle to the King's College to the National Gallery, St. Paul's Cathedral. All of these structures rely to some extent on very early smoke detection systems. You may not want water because you have very sensitive contents. One of the early projects I worked on was the Griffith Observatory. The observatory had extremely expensive equipment inside of a historic structure. So we had, on the one hand, equipment that was sensitive to water damage. On the other hand, a historic structure with a planetarium that was difficult to modify. And also just the concern that, we need to actually maintain a public facility operational. It was in effect a public place. And so we have an obligation to make sure we provide the best forms of protection. St. Patrick's Cathedral, shown on the screen, is the largest neo-Gothic style Roman Catholic cathedral in the United States. It's, you could say, New York City's Notre Dame. This building was first constructed in 1858, and it was renovated recently. One of the systems that was added in the upper roof area was a high fog system. This high fog system used approximately 1/10 of the amount of water of a standard sprinkler system. It was effectively able to control the fires that might happen in the concealed combustible spaces, much like what we saw in Notre Dame. Fortunately, they did install the system. There were a few, like any project, there were a few issues getting it up and running. But once it was up and running, they had a level of protection that would ultimately prevent and should ultimately prevent the same kind of outcome as what we saw in 2019 at Notre Dame. So little technologies can make a huge difference when you think about the destruction that a typical fire causes. Many times we worry about water damage, but what we have to be thinking about more so in many cases is the fire damage. While it's true that you're more likely to potentially have an inadvertent activation, it's also true that the outcome of an inadvertent fire can be much more severe without it. And the beauty of the water mist is that it uses a fraction, literally a fraction of the water as a standard sprinkler system. The heads are discrete, and it's far more effective at controlling spaces, heat in spaces. Smoke venting and control. Sometimes we will take an existing historic building and we'll open it up. We'll provide operable windows or a vent at the top. This will allow for the continued or modified use of that building by allowing smoke and heat to vent from that building during a fire. This could be done with an automatic smoke control system or through natural venting, as was the case at the Academy Awards Museum. In fact, the Academy Awards Museum used a combination of mechanical smoke control and natural ventilation to achieve enhanced life safety. And this life safety wasn't just life safety as for the building occupants, it was for the safety of the structure itself. Because when you remove heat, you inherently remove threats to the structure. The Tweed Courthouse is my first case study. This is in New York, New York. This is a beautiful example of a restoration to allow it to have a versatile use moving forward. It was in 1859 that the design competition started for the new courthouse. In 1861, construction began for what was then a county courthouse. There was a scandal shortly thereafter. Construction stopped and the trial began. Resumed in 1877, 5 years later. And finally, by 1881, the Tweed Courthouse was complete. The building is neo-Romanesque, marble palazzo typology with a central rotunda. Here you can see grand open stairs on either side of the rotunda. And then you can also see what are now enclosed stairs that are existing just north of each of the open stairs off of the rotunda. These monumental staircases served as the primary egress from all floors. So what was done here is an example of a points-based system where you start out with the three general categories. That includes fire safety, means of egress, and general safety. You looked at the existing conditions and the proposed conditions, and you utilized the scoring system to look at what your proposed changes are doing versus what the existing building condition is. And at the end of the day, you can quantify in a relative basis the actual improvements to fire safety, means of egress, and general safety for the building as a whole. And this was something that was based on assumptions and performance-based design, as well as some prescriptive options. But at the end of the day, the building was allowed to remain with its central grand stairs serving the rotunda open on all levels. Minor modifications made to enclose the two other stairs, but overall this was a success in terms of allowing for the continued use of the structure. In this second case study, we were dealing with a historic printing press building in Costa Mesa, California. It was ultimately used by the Los Angeles Times. The building in Costa Mesa entailed the thoughtful adaptation of an existing industrial building into creative space and a food hall. So in this case, there was a desire to preserve, not because of a mandate from a historical building code, but primarily because they needed to adapt it for a kind of use for which it would be best suited in the future. And the existing structure was beautiful enough that the architects, the owners, sought to maintain that as a central feature of the new design. And this is like any good building. We see it has 9 lives, but you have to look at what are some of the things that you need to do along the way to ensure that next life will actually come to fruition. The design drivers in this case were functional retail that they needed. So they needed multiple levels open within the space. Because this is in Southern California, there were indoor-outdoor experiences that are integral to the success. There was a large assembly use planned for the space that was obviously not part of a press building. So normally you would think this is the place where you get the book thrown at you. And pre-existing structural and other construction conditions did not always make it possible to easily adapt the existing building for those uses. So what the team did together is they used the California existing building code as a starting point. They applied the best practices for new elements using the standard building code based on the International Building Code, and then mixed in performance-based design. Instead of looking at the building as a series of pieces, the building was looked at as a whole. And this is when we were able to take advantage of many of the beneficial features of the existing construction relative to the safety of the new building. Now, in the new construction, you would typically be required to have fire-resistant construction throughout. But with this type of approach, it was able to be demonstrated that a level of safety could be provided for the structure, for the occupants, and for firefighters that would allow you to remove some of that fireproofing down the road that would have otherwise been kicked in because of the change of use. And the most remarkable portion of this is that the analysis had to be done assuming that sprinklers did not activate. In opening up the space, in fact, none of the sprinklers were actually brought into any portion of the analysis for the structure. This was a lesson that had been learned from World Trade Center. And we always think of World Trade Center 1 and 2, but World Trade Center 5 was a moment of inspiration for many engineers. What we learned from the failure of World Trade Center 5 was that the types of connections that you have make all the difference in terms of a building's performance in a fire. If you apply fireproofing, it doesn't mean that the structure will necessarily perform the way you think it does using what's called indexed fire protection. That's simply when you have a structure that you say, I want 1 hour of fire resistance. Well, does this mean the building will absolutely stand up for 1 hour in a fire? It may not. What they realized in the collapse of World Trade Center 5 was that the types of connections that could arrest collapse, the types of connections that could actually keep the building and its occupants safer, even without fireproofing on all of the structural members, was one of the things that really mattered. So the analysis that was undertaken used the approaches from ASCE 7, Appendix E, in conjunction with design fires established by the Society of Fire Protection Engineers and other methodologies for scenarios established by NFPA. And this analysis was implemented across the actual structure for the press. Here you can see the type of column tree connections that failed in World Trade Center. And it was exactly these types of connections that could be upgraded to yield a significantly and quantitatively better result for an existing structure. Again, the process was simple. You looked at the fire exposure in the building, the thermal response, and then what's the structural response to that fire. We set up briefs and had discussions with the authorities, and ultimately were able to use and include new natural ventilation openings in this old historic structure without compromising the integrity of the historic fabric, and get a new continued use out of this structure that also met the aesthetic concerns of the design team. There were areas where structure was removed, and we were able to demonstrate through analysis, using CFD analysis in this case, that we could maintain a safe condition and maintain tenability for occupants for the proposed new conditions better than even the historic condition. Finally, the fusion of old and new. The Academy Awards Museum, the Academy of Motion Pictures and Sciences, created a museum in Los Angeles that was recently opened. The museum included a new component by Renzo Piano, mated with the existing May Company building, which was an historic structure. Together, these two elements operate seamlessly and are interconnected on a normal day-to-day basis. So mating an historic structure that is something that has registered features with a new structure is certainly a challenge, but it's another example of where the hybrid approach works very well. Museum design is driven by the need to maintain that balance, controlled exhibit space and inviting navigable spaces with actual safety. And there's an aesthetic mandate which drives this. So this was taken to heart. And again, natural ventilation was looked at in the new portion, and mechanical ventilation was used to exhaust the existing portion of the museum that's historic. And together they worked together to create a safer overall concept for the building. And here again, we were able to prove that sprinklers were not even necessary to allow for the control of certain types of fires, and that the structure would ultimately not be damaged in those types of scenarios. So again, it's about combining solid code basis with performance-based design aspects that allow you to look at things a little bit differently and meet your objectives, whatever they may be. So in conclusion, historic buildings are frequently characterized by inherently fire-resistant features. They do not necessarily employ technologies or methods that we use today, but certainly they employ the technologies and methods that were appropriate to the design at the time and that were commonly in use and that allowed them to make it to current day. When we upgrade these facilities, we have to remember the codes and standards provide incredibly useful methods for evaluating the safety. But when you come up against a specific challenge, such as I can't provide sprinklers up in this bay, or I have a sensitive ceiling because of the artwork painted on the ceiling, that's when we introduce performance-based approaches, either as a part or a whole, to analyze those conditions. Ultimately, we usually arrive with a hybrid design, which includes the aspects of prescriptive and performance-based assessments that allow us to assess specific hazards that may arise for a given structure. This approach requires that we first know about it, but then that we establish a partnership with the authorities having jurisdiction and the design team and owner. By working together using these methodologies, more and more of these types of historic buildings can be preserved in a way that's true to their origins or true to the intended use that they are being designed for. And that may be a new use for some of these older buildings. Thank you very much for your time, and I hope you enjoy the rest of the presentations.
Great, Nathan. Thank you very, very much. I have some questions and some other questions that have arisen on smaller Main Street buildings. Again, we've got a lot of mixed use structures, 2, 3, 4 story, 3,000 square foot per floor. We've got issues, of course, of cost and of the availability of water. And so when sprinkler systems go into these buildings, when they do, can you describe the most common system that folks are going to get? Many also are in smaller communities where there's not access to fire protection engineers designing the system or really sophisticated installers.
Right. Yeah, that's a great question. We have a few choices. The first, of course, most commonly for commercial would be NFPA 13. But I think a lot of people understand that when you have a limited water supply, NFPA 13 may not offer the best solution, because as soon as you start to implement the 13 system, you're really looking at substantial work potentially underground, and that can be one of the triggers for significant costs for a project. I think it's important to sort of to frame this in terms of what are the expectations. Fundamentally, if we look at the types of sprinkler designs that we could implement, for example, NFPA 13 typically for commercial, 13R for residential and larger residential, 13D, of course, typically being associated with 1 and 2 family dwellings. These systems have different goals and objectives altogether. So the 13R, 13D are principally about life safety, whereas 13 is about life safety, but also property protection. And one of the things that you can do, though, is if you say you have access to enough water to the 13R or 13D system, so this will buy you some level of, life safety and property protection, but you don't have the water supply for the straight 13 system. Well, this is where you can look at other options. There may be features or built-in elements that, can help protect your building or your contents, but you're not necessarily obligated to go there either. The primary intent of the codes is first to provide life safety, then property protection. Some particular projects, however, you have a special call for property protection as well. So you just have to align what your choices are for the sprinkler system with what your overall objectives are.
Have you seen much relative to exterior sprinklers in terms of Main Street type areas, I guess, in particular?
Yeah, certainly. Exterior sprinklers or sprinklers on the inside used to protect against exposure, those are two potential options. So when we talk about exterior sprinklers, I think we're really talking about protecting one building from another and trying to limit, fire exposure. Where you also see this, for example, is something that's very different, but the wildland urban interface. Some people are looking towards exterior sprinklers there for the same exact reasons, that you can actually protect buildings rather well with these types of systems. You'll find in many jurisdictions that when you have like zero lot line conditions that are there, and you'll have openings that magically appeared at some point. And you can't necessarily eliminate the opening or, affect the property line. So the use of these sprinklers, sometimes on the inside, sometimes on the outside, sometimes both, becomes a good alternative, even though it's not something you would do with the new code.
We have some questions coming in about mist systems, and I just want to preface it that I've been involved in a project where they are tearing out a mist system, and it primarily seemed to be because the facility folks, small facility, but there were facility folks, never got comfortable with it, and they had the maintenance of it was somewhat beyond them. And I was very, very surprised that was the decision that was coming on a mist system. But the other question really about, and I think a little bit more on the mist systems, because they're not your ordinary installation. And if you could speak a little bit to the relative cost of a mist system and what you would expect also with a regular 13 on a full rehab, nothing terribly complicated, but on a Main Street full rehab, what we could expect.
Sure. Yeah. Let's start with the 13 systems. The mist is a little bit more mystifying to try to cost out. The 13 system, you'll see anything from, say, if it's a 13D, you'll see price ranges somewhere from, say, $1.60 to $2.50, up to 1% of the cost of the building. If it's a 13 system, it used to be you could reliably look at something between $5 and $7 a foot. When you're getting into historic structures, though, you're often dealing with masonry or difficult existing conditions where there's quite a lot of extra work. So it really depends on your location. If you're trying to install sprinklers in a historical building in more of an urban location like New York City, going up to $17 a foot is not unusual. If you're trying to do it sort of in middle America, I think you can count on something closer to, $6 to $7 a foot. $5, $4, I think that's still optimistic, and especially for smaller structures, because there are so many one-time cost components in a 13 system that go into that cost. The mist systems are a whole different beast, and I think you hit on something that is probably one of the biggest challenges that plagues the mist system, which is they are not that common in the United States. For various reasons. We don't have as many manufacturers who are dealing with mist systems. We certainly have them, but when you look at the types of systems, for example, that I was referring to in my presentation, we typically have to go to Europe to look for, these manufacturers. This is a huge problem, because most people are just comfortable, where do I get my maintenance? What happens? How do I get clear direction on that? So that can be an issue, and you have to make sure that the maintenance is on board with whatever decision you take. This was one of the same types of problems that that plagued fire protection in general when we went into places like, first went into places like China or the Middle East, where these systems, NFPA systems, were being introduced. There wasn't a maintenance culture, so it took many years to develop. We are developing that culture for mists, but some could argue that maybe we're not quite there. But the benefits can be tremendous. They're far more effective in terms of how they control fires, especially in these types of spaces. But you may be, if you're dealing with an out-of-country installer or very few options, you may be an order of magnitude more in initial costs. You really have to make a decision. How important is that property protection to you? And I had mentioned in the chat, okay, Notre Dame, what happened? Well, they had smoke detection, and it was supposed to alert people right away. It did. It actually worked. The problem is people had to notify other people. People couldn't be reached. Delays went on, and fires are exponential. So if you can't afford to go with the mist system, make sure you cover all the bases with your other type of life safety system, whether that be something like a standard 13R system or 13D modified sprinkler, or something like smoke detection. You just have to make sure you go from A to Z in that type of system and don't leave any holes where you can have delays, because when you're protecting a historic structure, time is the big enemy.
We've got some comments around cost and unaffordability of sprinklers, and that's you've touched on that. And I know that Mike's going to show us a community-wide water system, some piping installed for long-term planning within a community. But one of the questions that came up is, have you seen any smaller communities with fire protection initiatives or planning that would benefit at least the water issue or the availability of water issue for main streets?
I think it is very much a cost issue, because the most common problem, of course, is at a large scale. So when you have a water supply problem, you have a couple of solutions. One is you provide your own water supply through a tank. The other is that you hook into the municipal water supply. If you're hooking into the municipal water supply, you'll find that this is where a lot of our smaller communities are really struggling, because to dig up, thousands and thousands of feet of pipe and lay 8-inch or 10-inch or 12-inch pipes, which is sometimes what you're required to have. Well, who pays for that? Do you have the structure, the infrastructure, in terms of, do you have development that can support that? Do you have residents who can support that? It's a real issue. So you find most common in rural places that you have a standalone water system, but that's more for industrial applications or other things. So I haven't seen a solution that's sort of a one-stop shop that, you can just, that the municipality has a magic solution to get water, other than just incremental improvements. So that's why sometimes you can't realistically just go, okay, I'm just going to throw in an NFPA 13 system. You have to think about all the different factors that can affect that safety. And that's why many of the codes, performance-based or prescriptive, they don't force you to put sprinklers in, but they're trying to get the effect of having sprinklers. And that can still largely be achieved when you look at a building a little more holistically.
That's great. I think we've picked up the content of many of the comments and questions. Mike, you got anything else?
Just one last thing that's come up on several cases, and it was the typical scenario where you've got a residence on the second floor and say it's a change of occupancy, and it may only be 1 or 2 units. So you're doing the second floor and you decide to put in your R13D residential system up there, which would be great, would not be that expensive. But when is there a trigger that also requires you to put the sprinkler on the first floor when you do it? Because that seems to be a target that we hear a lot about.
Yeah.
What does the code say?
Well, let me first say that there is, in NFPA 13 in the codes, there is this notion of partial sprinklering, but you will find great opposition or high levels of conservatism in how that's applied. The concern that the authorities have is that when you apply a partial sprinkler system, they may go to a building and they assess what they have to do based on, well, is the building sprinklered or is it not? Because they're going into the fire. So they want to know, what are my risks? And if you have for example, it was very common to sprinkler basements, but not anything above grade in many of these older buildings. And when you have a sort of an unknown location of sprinklers, the AHJ is put in this uncomfortable position where they have to assess, well, am I allowing the fire department who's responding to the fire to misjudge the level of safety? And that's the big concern. So it's a human issue. It's that you will hear our policy is to not allow partial sprinkling. But if you go to the codes, there's usually a recognition, even in the allowances for omitting sprinklers. And, if you think about it, NFPA 13R, 13D are basically partial sprinkler systems relative to NFPA 13. You're eliminating sprinklers from some areas, but not from others. So it's a human issue, and you have to come to terms with dealing with the particular authority having jurisdiction to make them understand the whys and the hows. Sometimes this is like it's very difficult, and other times there's a level of understanding there. So it's tricky because it involves us people. That's what I'll say.
Good response, Nathan, and I think I've been there at that front end of that intersection before.
Yeah.
Thanks again for this wonderful presentation on a complicated topic. As you've heard from many of our discussions today and yesterday, the change of occupancy is frequently the major trigger that requires some level of action. Our next session, we're going to hear from an expert looking at what does change of occupancy and related change of use mean, and how does that affect? Our speaker is Chris Rute, who's an architect from Milwaukee, Wisconsin, and one who also spent a career in the Milwaukee Building Code Department. So he brings the skills from the architecture and the code side, and he's got a lot of enthusiasm for historic preservation too. So next up, Chris Rute and change of occupancy.
This presentation is based on the most recent edition of the International Existing Building Code, or IEBC. Please note that various jurisdictions may or may not have already adopted this edition and may have additional requirements over and above those mentioned here. While there are some changes that are new to the 2021 edition, the basic concepts presented here are consistent with those of previous editions. No matter what edition is currently adopted, the application of the IEBC remains the same. IEBC Chapter 10 is part of the Work Area Compliance Method. This is one of the three paths provided for by the IEBC and discussed by Marilyn Kaplan yesterday. All the chapters listed are integral to successfully executing the Work Area Compliance Method. Chapter 7, Level 1 alterations, is a minimum degree of intervention. Chapter 8, Level 2 alterations, minimum degree of intervention with reconfiguration of space. Chapter 9, Level 3 alteration, is the highest intervention and is greater than 50% of the area of the building. Chapter 10, the change of occupancy provisions, change of the use of an existing building, likely also involves level 1, 2, or 3 alterations. From there, we go to chapter 11 for additions, special provisions for additions to existing buildings, and chapter 12 for historic buildings, and the special provisions that the code allows for those designated as historic. It's important to clearly understand how the occupancy or use of a building is critical and why a change in occupancy requires a specific chapter. The IBC is an occupancy-driven code. Of those occupancies, we deal with assemblies where large numbers of people gather for sports and entertainment venues, for instance, churches or libraries. B occupancies are business, office-type environments and colleges. Education, E, deals with schools through the 12th grade. We have factory occupancies that deal with industrial manufacturing facilities. We have hazardous materials, hazardous occupancies that deal with materials that go whoosh and boom, and methyl bad stuff, as we call it. Institutional are the hospitals, our prisons, and our daycare facilities. M occupancies or mercantile are retail facilities from small shops to the big box. R is a residential, they're apartments or hotels. S is storage, like warehouses. And U, not shown on the slide, are small sheds and garages and lake. Because the varied uses have different requirements for each occupancy and are based on the potential hazards that will be of concern. This is easily understood when that limits on building heights and areas, exiting requirements, the active and passive fire and smoke protection control feature thresholds, the required fire resistive ratings, and interior finish attributes are different based on the occupancy of a building. For instance, an assembly occupancy where large numbers of people congregate for several different purposes offer a different concern or hazard than does a warehouse where few people are present. Similarly, an office building that is normally occupied during daylight hours, and while most people there are awake, as compared to an apartment building where cooking is done and people are asleep, each presenting varied hazards and requiring a different approach to their mitigation. In an existing building, then, it's important to clearly understand why the occupancy or use of a building is so critical and why a change of occupancy requires scrutiny. Definitions provided in the code are of great importance. They provide an ability to speak the same language. IEBC Chapter 2 defines a change of occupancy, as it's shown here. And each of these items bear some further explanation. A change in occupancy classification of a building or structure. This is the easiest to understand and identify. It involves a change from an office building, a B occupancy, to a hotel R1 occupancy. Another example would be a big box retail M occupancy being converted to a church in A3 occupancy. And one more example would involve a warehouse S1 occupancy to an apartment R2 occupancy. The second, any change in the purpose of or change in the level of activity within a building or structure is also considered a change in occupancy. This one's a bit more nuanced. For instance, a change from a family restaurant to a nightclub would offer very different concerns, yet both are considered A2 occupancies. No change in the occupancy classification. Or for instance, increasing the number of living units in an apartment building by subdividing a couple of apartments would be another example where this would be a change of occupancy. And then we have change of use. Change of use is now defined in the IEBC 2021 version. One example of this is a retail store, an M occupancy, that begins to sell upholstered furniture. Now, it's still a retail store, but it's starting to sell some additional types of materials that burn a little bit more readily. Therefore, now a sprinkler system would be required. Another example would be converting a doctor's office into an ambulatory care facility where outpatient day surgery was being performed and where patients might be limited in their self-preservation capability. So a distinction must be understood between change of use and change of occupancy classification because they both trigger very different code requirements. Hopefully, we have an understanding of the concept of different code requirements based on the use and the occupancy type, and of the distinction between the change of occupancy versus the change of occupancy classification. With that understanding, we can now look at some of the specific requirements of IEBC Chapter 10. IEBC Chapter 10 sections 1001 through 1010 will apply for all three occupancy scenarios we discussed previously. This first section here is the general scoping section and provides a distinction between the requirements for a change of occupancy, in which sections 1002 through 1010 will apply, and the added requirements when a change of occupancy classification is proposed. So sections 1002 through 1011 will apply in these situations. Section 1002 is critical because it stipulates that if a building undergoes a change of use to one of the special occupancies of Chapter 4 of the IBC, such as covered malls, atriums, underground buildings and such, the IEBC is not applicable to that portion of the building where those special occupancies are proposed or exist. The provisions of the IEBC are not adequate to address the hazards that the special occupancies offer, and as such, those occupancy types must meet the requirements for new construction as found in the IBC. Now, this will rarely impact buildings of the size and scope found on most Main Street scenarios. There is, however, a project currently underway here in Milwaukee that is altering an existing office building to remain an office building, but they're creating a new atrium inside. And most of the alterations are designed to meet the requirements of IEBC Chapter 9, as the alterations work involved over 50% of the building area. The atrium portion must meet the requirements for atriums as found in IBC for new construction. Another potential would be the conversion of a single tenant retail facility being converted to a multi-tenant where a covered mall provision would be applied. Here too, the entire building would be evaluated for compliance with the IBC requirements equal to those in new construction. This section also addresses certain incidental uses and limited healthcare uses. Section 103, building elements and materials are only dealt with or impacted if a change of occupancy classification is involved. In other changes of occupancy or use, the building elements and materials will be addressed by the applicable alteration levels in chapters 9, 8, and 7. Section 1004 deals with fire protection requirements, which will be brought to bear for changes of occupancy classification, as well as when the change of occupancy moves to a use with a different fire protection threshold. The two examples mentioned earlier where sprinklers would be needed was a retail facility adding upholstered furniture to their offerings, or when the doctor's office begins to perform day surgery. In section 1005, unless a change of occupancy classification occurs, egress will also be addressed by the preceding alterations chapters. Section 1006 deals with the structural issues. This section speaks to the structure of the existing building. Even if there's no change of occupancy classification, the potential for higher structural live, snow, and wind load requirements does exist. Corridors in an office building have a higher load requirement than does the office space itself. So reconfiguration of a floor plan might result in newly formed corridors, and the structure for those new corridors must then be verified to meet the current requirements. Similarly, the existing building structure may need to be evaluated for adequate snow and wind loads for the new use. Section 1006.3 speaks to the structural issues related to seismic concerns for existing buildings in earthquake-prone areas. Since structures is a bit beyond my pay grade, I won't go too deep into it. Suffice to say that a potential consideration in your friendly neighborhood structural engineer should be a part of the project team early in the design phase. Section 1007, certain special occupancies that offer specific electrical concerns require improvements or upgrades. Most of the special occupancies are less likely to impact typical Main Street projects. Places of assembly such as churches, museums, theaters are some of those types of special occupancies. I mentioned this simply to alert you to the potential. Also, we need to be aware that unsafe conditions, electrical service, and numbers and locations of outlets may need to be upgraded to current standards. Mechanical systems may also need to be improved to meet current exhaust and ventilation requirements of the proposed new use. And lastly, we have section 1009 dealing with plumbing fixtures. The plumbing fixture counts are required to be increased to meet the demand for the new use. For instance, a modification to an existing restaurant that results in an increase in the number of occupants would require additional fixtures to be installed. A new exception that was added in the 2021 IEBC provides some relief if the occupant load is increased less than 20%. Section 1009 also includes some additional requirements when a building undergoes a change of occupancy involving food handling establishments, grease traps, chemical waste, and mechanical facilities. Now, this section 1010 is basically a catch-all for all other requirements. And to date, this section is only speaking to a natural light and ventilation needing to be increased to meet the IBC requirements for the new occupancy. As you can see, there are a limited amount of code requirements for a change of occupancy in general. In addition, though, requirements from a level 3, 2, or 1 alteration need also be taken into consideration. It is when a change of occupancy classification is proposed that significant additional requirements must be met. So let's take a look at some of those. It is IEBC section 1011 that may be most likely applicable for revitalization projects on Main Street buildings. Buildings formerly used as offices or for manufacturing might be converted to multifamily residential with retail or restaurants on the first floor. And these are some examples of a change of occupancy classification. It's important to note that this section will also apply to a change of occupancy that is proposed that has a different fire protection threshold. It also reminds us that the requirements we went over previously, section 1002 through 1010, will also apply. Fire protection requirements are the first then to be addressed. I have heard it stated that this is likened to a change of occupancy penalty, and to a degree I understand that. The alternate performance compliance method Marilyn spoke of yesterday exists and will be discussed in depth tomorrow. This strategy helps to potentially avoid the sprinkler requirement. The significant distinction between the IEBC and the IBC for new construction is the allowance for non-rated permanent walls and floors, smoke, fire partitions, or barriers to limit the area of mixed-use buildings so that will need to be sprinklered in this situation. In new construction, the IBC often requires the entire building be protected, or a firewall would be required to create two separate buildings. In a very similar fashion, fire alarms are handled the same way. They are required, if they're required for the new occupancy, they are to be installed in the area undergoing the change of occupancy classification, as long as there is a wall that separates the unprotected and the protected space. As an example, I've created a plan view here where the north side of this area is undergoing a change of occupancy classification that triggers a sprinkler or alarm requirement. With that wall between the space and the south side area, the sprinkler or fire alarm will only be required on the north side. Similarly, if we were to look at a section view of that same building, where the second floor, the floor where the change of occupancy classification occurs, will need to be provided with the sprinkler system. However, no sprinkler or fire alarm would be required on the lowest level. I've got to make a personal note of caution here, because sprinkler systems are designed to limit the spread of a fire at its incipient stage. The potential challenge would be that a fire starting in the unprotected portion of the building and then spreading to the area protected with a sprinkler system might be of a size that would overwhelm the sprinkler system. Also, the largest significant cost associated with the sprinkler system in an existing building would be bringing the water main to the building and the riser piping and its appurtenances. Once this is done, the sprinkler piping to an entire building may not add as much or more cost, depending, of course, on the size of the building. This section is easy to understand that interior finish requirements need to be brought into compliance with those for the new occupancy classification. The flame spread and the smoke development ratings are important life safety considerations. Of course, beyond fire sprinkler and fire alarms, the next significant areas of concern when a change of occupancy is proposed is egress, the ability to get out of the building in an emergency situation, of course, height and area of the building, and the location of the building on the lot. Each of these areas of concern are dictated by the occupancy of the building, along with other factors. As we will see, a change of occupancy to a higher hazard will mandate compliance with the code requirements for new construction with some reasonable exceptions. Conversely, a change of occupancy classification to an equal or lesser hazard will render the building compliant as is. I refer to this as the risk index system. Let's explore each of the three in more detail. Table 1011.5 speaks to egress. Safely exiting a building in the event of an emergency is a key tenet of the building code. This table indicates the relative hazards for each occupancy classification regarding exiting. High hazard occupancies are the highest, and the factory F2, storage S2, and utility U occupancies being the lowest. So the next code section just tells us that this requires the entire means of egress system to be evaluated and, where necessary, brought into compliance with the requirements for new construction. There are a few exceptions worth noting. The first three here make allowances for existing stairs that would be difficult to be brought into complete compliance with IBC Chapter 10 for new construction. These include upgrading the enclosure, acceptance of existing handrails and guards subject to the approval of the code official, and a provision for replacing stairs in an existing enclosure that failed the minimum tread and maximum riser dimensions. These exceptions address corridors, reducing some of the requirements that might otherwise render a project infeasible, such as the allowance for lath and plaster as opposed to a new wall, transom openings to be allowed to remain, and existing dead-end corridors being acceptable. And the last exception would allow at least a less restrictive alternative to emergency escape and rescue window requirements when they exist and when they're required. And for the most part, a means of egress system is deemed acceptable when the change of occupancy classification is to one of a lesser or equal hazard. The code does refer us to IEBC section 905 and then subsequently section 804 and 704 for potential improvements to exiting based on alterations. The exception that we see here mirrors that included in the previous section for stair reconstruction in confined existing shafts. It must be noted that any new construction or modified portions of a means of egress must comply with the requirements for new construction unless it meets the exception criteria. A few additional exiting requirements are noted. Exit sizes must meet or exceed those needed for the new occupancy. Existing handrails or guardrails must conform to the requirements of those elements as specified in IEBC Chapter 8 for Level 2 alterations. Exception 7 of IEBC 1011.5.1 that we looked at earlier refers to this section for minimum requirements for emergency escape and rescue windows in an existing building when they're required, making allowances for existing window sizes that do not meet current requirements for such elements. And now we can move on to allowable heights and areas under table 1011.6. The existing building undergoing a change of occupancy classification must be evaluated. Allowable height and area for buildings is a function of the building's class of construction and its occupancy classification. The less combustible a building is, the larger it can be in general. Similarly, the greater the capacity for self-preservation an occupant has in an emergency, the larger the building is allowed to be. As you see here, the relative hazard ratings differ from those for means of egress, but they're all identified. A change to a higher hazard will require the existing building to be evaluated for class of construction to determine if the allowable area for the proposed new occupancy classification is if it were a new building. If the height and area of the existing building exceed those that are allowed for new construction, aggressive and costly modifications would normally be required to improve the class of construction to one that allows the existing height and area for the proposed use. Firewalls, reducing the size of a building area by creating smaller separate buildings, may be one way of overcoming an area excess as well. A careful study will be needed to determine if this is feasible. The exception that we see here speaks only to high-rise structures and is not going to be all that applicable in most Main Street scenarios. There is, however, a firewall alternative that we have, and this section allows the use of fire barriers and rated horizontal assemblies to create separate buildings for the purposes of applying the height and area requirements. This allowance comes with 3 conditions. The first is that it requires that an NFPA sprinkler system be installed throughout the entire building. It limits the allowable area between the fire barriers or horizontal assemblies to limits them to an area that does not include a sprinkler increase. And ratings of fire barriers in accordance with the firewall ratings of Table 706.4 of the IBC are required to enable us to take advantage of this. But this section does provide the necessary flexibility in meeting height and area requirements in existing buildings, such as old mill complexes, where achieving the height and area limitations is very difficult. Of course, when a change to an equal or lesser hazard is proposed, the building area and its height are deemed acceptable as they are. This provision here regarding fire barriers requires that fire barriers are in compliance with IBC in a mixed-use building where the proposed change of occupancy is made to a higher hazard. The exception recognizes the ability of existing plaster and lath construction to provide at least a 1-hour fire resistive rating, which is very helpful in many instances. So now we've looked at exiting, we've looked at area limitations and height limitations, and now the third element is going to be our exterior wall requirements. They are based on the class of construction and the building's fire separation distance. That is the proximity to property lines and other buildings on the same site. The rating of exterior walls and the area of openings are of concern to minimize the potential for spread of fire from one building to another. Once again, we see the relative hazard rating among the occupancy classifications has changed a bit. A change to a higher hazard will require the existing building to be evaluated for class of construction, exterior wall ratings, and exterior wall openings to determine if those elements meet the requirements for the proposed new occupancy classification as if it were a new building. According to IEBC commentary, the exception here is somewhat academic in that these occupancy classifications listed there are never required to have a 3-hour fire resistive rating on exterior walls. I would imagine that at some point those will be changed in the near future. And here we see that consistent with the height and area category, a change to an equal or lesser hazard will consider the existing building exterior walls and openings to be acceptable as they are. This section here deals with our openings, our windows, and that sort of thing, and when they have to be rated. This section offers some additional relief for existing buildings where a change to a higher hazard category is proposed. The significance of this section is that it imposes a maximum area of openings to be 50% of the wall area when the fire separation distance requires opening protectives, even though it may exceed the percentages given by Table 705.8 of the IBC for new construction. Some additional exceptions make it easier to deal with the openings in existing buildings in certain situations. Of course, if the IBC allows more than 50% of unprotected openings, the 50% limitation would not apply. Similarly, protected openings are not required for low-rise residential buildings or buildings protected with a sprinkler system, nor when the change is to a lesser hazard of occupancy. Shafts of any description, be they for stairs, for elevators, ventilation, they're all conduits for fire and smoke migration from lower levels. Smoke is known to be the deadliest component in a fire event. And when a change of occupancy classification to a higher hazard is proposed, the requirements of this section are to be met to further prevent migration of smoke and fire. So in summary, Chapter 10, Change of Occupancy in the IEBC 2021 is an integral part of the work area compliance method. A change of occupancy is I'd say, second highest level of alteration to an existing building, additions being the highest. So we go from level 1, level 2, level 3, a change of occupancy, and then additions as the hierarchy. A change of occupancy classification to a higher hazard requires significantly greater life safety measures to be provided that will emulate those required for new construction. Provisions do exist, however, that will relieve some of the code requirements that could limit the success of a proposed adaptive reuse of an existing building. Thank you.
Thank you, Chris. I think you got the hardest part for the day. That's a tough chapter, and you explained it clearly. I got kind of a step back to ask. On the Main Street buildings, the smaller mixed-use buildings we're talking about, what changes of use or occupancy, in your experience, are the most difficult to implement on the lower budget projects? Or alternatively, what are the ones that are easier?
It depends. You know, they all come with their own level of complexity and ease. The ones that I thought were going to be slam dunks turned out to be major malfunctions, and the ones that I anticipated to be challenging turned out pretty clearly. Usually the change of use to a residential is the one that offers the most consternation to the development community, simply because once you change from any lower hazard like a B occupancy or a storage occupancy, you're suddenly brought into that sprinkler requirement, and that is a pretty big ticket item. As we know, and as I said, most of the cost is just bringing that water main to the building and the riser and that sort of thing. So those are the ones that offer, I think, the greatest challenge when using the work area method. Once you go beyond that, if you start to explore the performance compliance method, which John Curley will be handling tomorrow, you will start to see where, and we actually saw an example of that yesterday as well, where you can avoid the sprinkler system. The rest of it is fairly straightforward. You can meet the building code requirements in Chapter 10 of the IEBC quite handily with an existing building. There's enough understanding that, like I said, the IEBC is intending to enable the adaptive reuse of older buildings to uses that heretofore they weren't originally designed for. So it requires a great deal of thought and following the work area method to its fullest. But once you tip over into Chapter 10, we start to see a little bit more complications added, a little higher level of scrutiny. And again, it's always based on the fact that the code is occupancy driven. It's much safer to be in an office building than it is to necessarily be in a hotel that you're unfamiliar with and you're staying there for a few nights. So that kind of is, it goes across the board. There is no clear-cut answer as to which one's most difficult or which ones are easiest. Easiest is no change in use at all.
You get credit for insomnia or something. Yeah. And beyond sprinklers, right? So some of the other items that we've collectively been discussing are requirements for second means of egress, and of course that tin ceiling problem, the separation. Any words of guidance there?
Yeah, I mean, I think the means of egress, having the ability to exit from a building that is in Gulf with flames is so important. I mean, the whole code, Chapter 10 is probably Chapter 10 of the IBC. The exiting chapter is probably the biggest. It certainly has the most meat to it. So the major tenet of the code is to enable an individual to egress in an emergency situation. So the other options that we'd have is to take a look. There are, again, the performance method, performance compliance method is another way of taking points, but even that requires that the exiting requirements be met. There's no, nothing, no negative points you can take for not having the adequate number of exits. So it's always going to be a critical element.
And my last question for the day is, what are your thoughts on that radical idea of if you have a separation using the IRC for one or two number of residential units, using the IRC on the upper floors?
Well, it certainly is inappropriate. I mean, here in Wisconsin, if you have one unit up there, you can use what we call here the Uniform Dwelling Code. The state of Wisconsin's comparable to the IRC. We have not adopted the I codes for the state of Wisconsin as of yet. So it makes sense to view the interior, but the building itself, the shell, still needs to be considered as a commercial building. So it's just the interiors that we'll be addressing and life safety aspects of the interior of the space.
Great, thank you.
Chris, another topic that keeps coming up in the chat room is change of occupancy depends upon knowing what's the existing occupancy, which can be a bit of a problem for a vacant building that's been sitting there for years. What advice do you have on dealing with that situation, the vacant building that's being now renovated?
Of course, I mean, my background was here in the city of Milwaukee, where we've kept records ad nauseum. So all the way, dating back to almost the beginning of time. But in small town Wisconsin, I know that there is always somebody who, whether they have been, involved with that city or that town for a long time, somebody knows what it was. And that's where, again, I think one of the greatest statements that was made today was get your AHJ, your authority having jurisdiction, that individual, that inspector, that development director, whoever, get them involved in this process early on, because they're going, I remember working on a project here in Milwaukee where the most recent use was a storage facility of a 4-story warehouse in the center city. And prior to that, it was a Schuster's retail store. So, but because it was a storage facility for so long, the city of Milwaukee deemed it that was the storage occupancy was the one that we would have to compare to with our evaluation of this building. We couldn't go back to M because M would have made it a whole lot easier, the retail occupancy. But the other thing is there's always some history. So I think Mr. Curley stated, they go back to some of their historic documentation. Most of those small towns even have that historic museum that somebody can tell you what that building was designed for initially, as well as tell you what it most recently was used for, even though it's been sitting vacant for many years. And there's so much forensic you can go into a building and kind of sense what it was being used for based on what was left behind.
Yeah, I always tell people if there's a kitchen and bath up there, it was probably residential the last use, but that's one of the obvious ones. But beyond that, the California Historical Building Code specifically states that it allows you to use the immediate prior use or any identified historic use as a earlier occupancy in calculating the change of occupancy. Any thoughts on that provision?
And I think that is a fabulous idea, because really, if you look at it, if a building was designed and constructed as a mercantile, for instance, going back to my project here in Milwaukee that I worked on recently, when it changed to storage because the retail facility moved out, it didn't degrade. It was no longer, it was not reduced to, in life safety concepts, nobody made any changes that reduced the life safety concepts that were already there for that building. So it really is, just because somebody took out a CEO, a certificate of occupancy for a storage facility, doesn't mean that they denigrated the building in any way, shape, or form, that it still is as safe as it was for that retail outlet as it is now. So yeah, it's something that I would consider as an appropriate change to the IEBC in future editions, and certainly consider that as an option.
Yeah, again, it sounds reasonable because it fits to what was the building originally designed for. We're probably not going to go to the original building code if it was an 1880s building, but this gets to that same idea. It was designed for that use and works from there.
That's true. Absolutely. And had it remained an M occupancy through this time, what's the difference? You know, and it's a distinction without a difference, I think, that we would say, oh, now it has to, it's an increase in hazard because it was a storage facility for 20 years. Even though it was designed initially as an M occupancy.
The change of occupancy classification, though, has a huge jump when you go from like a two units to 3 units. All of a sudden, you go from R3 to R2, which is then a much higher hazard area. Mm-hmm. There seems to be no gradation in that. It's like, you know, very small. We know that Memphis has moved to up to 6 units being considered as a residential occupancy. Do you have any thoughts on that?
Yeah, and you know, and I've looked at that for a while because you know, the R3 differentiation between R2 and R1. You know, when you look at those hazard categories, we're looking at just those regarding egress and heights and areas, but not in exterior wall ratings. But the R3 to R4, if it's a change from a B occupancy, even if, since B and R3 are the same in that in those hazard levels for means of egress, for instance, the previous section in chapter 10 that deals with fire already tells us that if you're changing to an occupancy that has a different fire protection threshold, you're going to need to bring it into compliance. So in this case, the only distinction is I still have to put in a sprinkler, but I may be able to do a NFPA 13D as opposed to the full-blown 13R that would be normally required for a multifamily residential. And in respect to the question that was in the chat about the R13, throughout the whole building, the answer would be no. NFPA 13, if you're going to put it in the B occupancy in the lower level, that system has to be, you know, totally compliant because the 13R is designed for a lower level hazard and a lower level of fire hazard. And as I said earlier in my presentation, not sprinklering that lower level opens us up to some potential challenges because a fire that occurs on the lower level, not unlike a fire alarm that's not there on the lower level, you know, or smoke detectors, you know, all of a sudden, by the time it gets to that sprinklered area, it's going to overwhelm that sprinkler, and the sprinkler system you put in is probably going to be less than effective. So I would caution anybody who's contemplating that kind of sprinkler the upstairs, but not the downstairs kind of approach.
Yeah, this comment has come up in the chat room as well, as conventions versus the code language and where we stand on that. But we're all looking for these creative solutions to make our buildings safer in incremental ways at the most cost affordable solution for small America in particular.
Absolutely.
We've just about finished up this week, or this today, I'm sorry. And this is the last session. Any final thoughts from you on the occupancy issues, what you think might be changed in any tweaking of the occupancy code provisions?
No, I mean, my only thoughts are, yeah, I remember when Wisconsin first adopted the IBC, and we had chapter 34 of the IBC, and that's all we really had to apply to existing buildings. And then it was the 2003 IEBC that we eventually adopted in the 2006 edition, which gave a significant toolbox to the designer and the code official alike to better understand how to what do you do with these existing buildings that don't meet today's more restrictive code requirements, but are safe. They're valuable assets that we have in our building stock, and that it's one of the most ecologically sound approaches to reusing the existing building because of embodied carbon and all that. So it's a win-win-win situation. I think, but what I've seen since 2003 to 2021 IEBC, the I folks are doing a great job of just improving upon it. And the great thing about it is that the design professional community and the code enforcement regulatory community all get together and make them better as we go. So, I see continued good improvements. There's always going to be, this group would want to have this and this group would want to have more of that. And, that kind of thing is always there, but it seems to be the whole code change process seems to offer a wonderful way of getting to just right. And, it's not a static situation. It'll never be finished. We'll always have new materials, have new techniques, have new ideas on how to make those buildings equally safe to those of new construction, and alterations and existing buildings is more difficult than new buildings. New buildings is pretty straightforward. You can build those relatively easily. It does require some real thought and a concerted effort on the part of the design community as well as the regulatory community to come together to make these buildings safe and viable. So
thanks again, Chris, for your being part of this
very welcome
and sharing your time with us in APT and our commitment to improve building codes. I've often stated to people renovating buildings that a completed renovation is an oxymoron. It's always just another step in the level of where we're going. And it sounds like code development is like that as well. We're going to continue to be with evolving the codes, improving them. And this workshop is really, I hope, opened up many people's eyes to some of the nuances and complexities of the building code and applying to existing buildings. So with that said, I'm going to wrap up today's session. Remind you all that we will start again tomorrow at 10 a.m. And we at APT are continuing to figure out how we will best make this available material later. So we've recorded it all, but we've got some work to do on our end before we get this out in a public platform. So see you all again tomorrow. Thanks again, everybody, for participating in this workshop.
Excellent. Thank you.